All right, so before we go through the homework for today and then continue on, um, let's talk about the exam. So our exam will be next Tuesday because this Thursday we are on fall break. And I assume everybody saw the note from the university. You are strongly encouraged to um, stay on campus for the days off or stay in the area. They're going to have a bunch of activities and things like that. I think they're trying to prevent max exodus from the university, then coming back and possibly having a breakout or something like that. But we recognize that students are free to go home during the weekends anyways. So if you already have plans, you decide that's what's in your best interest, then do it. The hope is that by giving a globally just consider staying here type situation, we hopefully solve some of the problem. So the exam will be a week from today. I'm going to have the exam on Blackboard. So I don't know that there's any reason to meet in class, but what I'll do is I'll just make sure I'm available and sitting at a computer and you can ask questions via Slack or something like that if you're confused as to what I'm asking or something like that. So I'll be live during class and able to respond, but the exam will be 10 questions um, online. So let me talk about kind of the format of the exam here. And what I'm describing here is pretty much what every Littman exam looks like for your 4 years. So, roughly this is how I break my exams down. So my exams all have 10 questions, and they're going to be designed to take about an hour. So even though this is an hour and 20-minute class, the exam is geared to be able to be completed in less than an hour. You have the full-time commitment or time period for the class. I try to write my exams such that they're not uh, a situation where you might run out of time. So I want you to show me what you know, not that I couldn't do it very fast. Now there's a point where if you're just super, super, super slow, that means you don't really know it and you're Googling everything and stuff like that, then maybe that doesn't make a whole lot of sense. But I try not to make it a time stress type situation. Also remember that if you do poorly on the midterm, you can replace that grade with what you get on the final, assuming you improve. Right, so it doesn't go both ways. It only, if you do better on the final exam than you did in the midterm, I'll replace your midterm exam grade with your final exam grade. You can't do well in the midterm and then just have that count as your final exam. So it only goes one direction. But hopefully that reduces some stress associated with the exam as well, where you maybe get a wake up call if this just doesn't go your way. All right, so as far as the format of the questions, I never ask true, false, or multiple choice questions, so there'll be nothing like those on there. So all of them will be short answer, SAE, or programming. The exam will be roughly half programming, and the half that those programming questions are going to come in the form of writing your own code, reading code that is already written, and you have to tell me what it does. And just to kind of throw a caveat on that, if I give you some code, so for example, if I'm showing you something like, like this for loop, and I ask you, what does this code do? I'm not asking you to go line by line by line, telling me what each individual line does. You can do that if you want, but I want to know is, as a whole, what does that code do? Or in this case, it's all under the for loop. So what this code does as a whole is it creates 100 people. person objects, 100 person objects, and adds them to a collection. That's what this code does. Okay, 100 random person objects where they have a first name, a last name, and a random age. So something along those lines. Tell me what the code accomplishes, not what each individual line does. Okay, because you can look at this line and say, oh, well, that's a for loop that just takes I on a voyage between 0 and 100. You should know that, and you can even write that. But if you just give me the lowdown in each individual line and don't actually tell me what the code accomplishes, I don't know that you can read code. Make sense? Okay, so there will be at least one question out there where I give you some code and ask you to tell me what this code does. And that's what I'm asking you to do. There probably will actually be a couple of those questions because think about what I'm trying to test here in the first 8 weeks of your programming career, let's say. I have the expectation that you're probably not overly great at just sitting down and writing code from scratch. You get it when you see the answer, but you have to kind of struggle with it when you're writing it for a while. So I'm probably not going to give you very complicated code to write yourself. That doesn't mean you shouldn't be able to write a for loop that, prints all the numbers between 1 and 100 by 2, something like that, stepping by 2. So, prints out a 1, a 3, a 5, a 7, that kind of stuff. You should be able to do those kind of things. And we'll go back and look at the couple of things from the lab. I think there was like a Fibonacci sequence one that some people seem to struggle with. So we'll look at that here today as well, just kind of some practice-y drill stuff. Okay, so that would be one kind of question that you might have for the programming stuff, writing your own code, reading some code that's already written, tell me what it does. That's going to be the programming type stuff. Now, other kinds of questions are going to be questions about the short answer, questions about, let's call it vocab / history, something like that. And I'm going to go through our earlier slides and kind of point out highlights, things that I think are kind of important and things that maybe are trivia knowledge, but not something I'm necessarily going to test on, something like that. And if you remember, as we went through these things the first time around, sometimes I would say, this isn't something I'm going to test you on, but something that you probably should remember. I'll kind of reiterate that as we go through here. But in general, are there any questions about the format of the exam or the kinds of questions I'm going to ask? Now you can use your calculator. It's closed book, closed note. Obviously, I can't, police that. Closed neighbor, so don't get together and work in groups on this. You're only hurting yourself. I'm not going to sit here and hunt around for people who have the identical answer to stuff. If you want to go that route, then it's on your own conscience. You only hurt yourself later on. So you're paying a lot of money for school. You might as well get out of it what you should get out of it. But I encourage you to use your own brain for your exam. But you can use a calculator. There will be at least one conversion question. Probably 2, since we've focused on conversion so much in that first 8 weeks. But really, this statement right here is true on any Lippmann exam for the next 4 years. I put conversion questions on every single one of my exams because that's something a computer scientist should know how to do in their career, not just in this class where we introduced it. So classes where we don't even talk about that as a topic will have a conversion question. 10% of your exam is a conversion question. These are things you should be able to do. So converting, some base 2 number to base 8 or to decimal or something like that. Also, the speeds to be able to go from megabits to gigabytes, that kind of stuff. All right, so let's kind of walk through our slides, and I'll point out some highlights up to this point. Certainly this concept, this how do human beings solve problems, this is something we've repeated over and over and over again. So this understanding that the job of a programming language is to allow human beings to tell a computer what to do. And it tries to meet us on, be convenient for us by allowing us to tell a computer what to do in the context of how we already try to solve problems. So this concept of memory, asking questions, and repetition, and then how that maps to a programming language is an important concept to know. That's probably going to show up on the exam in some format. So these couple of slides here. All right, I'm not going to ask anything about HTML. I mean, I'm not going to ask a question like, why is programming hard? You should have an appreciation for that, but those are not the kinds of questions I'm asking. When we start getting into the slides about the different kinds of languages, procedural versus object-oriented, stuff like that, I would say they're fair game, but I'm probably not going to ask a question very directly with that. I might give you, so if you think about some of the things we've talked about, I might be more interested in, like, for instance, Python being an interpreted and loosely typed language. If I brought up something, I asked a question about that, it might be more along the lines of that particular aspect of Python being, since it's interpreted and since it's loosely typed, what does that kind of mean? It generally means that it's going to be somewhat slower. You don't have to define the kinds of values you're going to store in your variables beforehand. Maybe it comes at that question from a little bit different angle where, you're looking at some code and I maybe put one kind of value in a variable and then do something with it, then I put a different kind of value in that variable and do something with it. I try not to trick you in the code. I want, so when I give you code that you have to read and then tell me, what does this do? My goal is not to like throw some kind of weird curveball at you and then like, only if you caught the trick did you get credit for it. I want you to show that you know what you're doing, not that you stumbled upon my trickery, I guess. You should understand what the premise of object-oriented versus procedural languages are. This is something we've just started talking about in an example in class, and we'll do our dice problem today. That was your homework due today. General purpose versus domain specific. I'm not going to ask you anything. We don't have context for that, so I won't ask you anything about that. Like I said, loosely typed versus strongly typed. I'd have to have the right kind of question in order to ask about that. I wouldn't ask about it specifically. Same thing with compiled versus interpreted. High level versus low level versus machine level. That idea of how does the CPU work, that's an important idea. I think that could show up on the exam, on this particular exam, in one form or another. Just so we get that idea that when human beings write that high level code that looks like English-like, eventually it has to run on the CPU. And what is the nature of the CPU? What does that guy kind of look like? So that's kind of what all of these things, these slides are. So the idea that the CPU is kind of a collection of magic tricks where each magic trick knows how to do something very small. Remember we were doing the little exercise, wiggle your thumb, move one finger. Nobody's impressed by those individual little things, but you put those things together, you can accomplish real tasks. So these are your conversion stuff, numbering systems. I mean, I probably won't ask you some sort of abstract question like, why do we have different numbering systems or something like that. It would be more, using it as a tool. Here's a number in base 10. What is its equivalent in hexadecimal? Something like that. As opposed to like, the closest question I could potentially ask, but I don't even imagine myself asking this as I just say it, is like, why are octal, hexadecimal, and binary popular in computing? It's that trick move between them. You can represent the entire octal octet space with 3 bits, You can represent the entire hextet space for hexadecimal numbers in 4 bits. So you can move between them very conveniently. That's an interesting enough concept, but from a practical perspective, those are the numbering systems that computers use. So it doesn't really matter why they chose them. We kind of just use those. So I can't imagine I asked that, but you certainly should be familiar with those base systems. It would be very fair game for me to say, you know, convert a decimal number to base 13, something like that. I would want you to understand that those patterns exist regardless of which base I'm going to. So even though we have names for some of the bases, base 13 exists. We just don't commonly use it or something like that. So here's a whole bunch of examples of those things. The shortcut thing is an important concept, going from like binary to hexadecimal, for example. So it would be fair game for me to put that on the exam. In the past, I have never forced you to use the shortcut. I will, you know, if you want to go the long way, you can. I would just make sure you familiarize yourself with that shortcut of binary to octal, octal to binary, binary to hexadecimal, hexadecimal to binary, because that'll save you time on the exam as opposed to having to do all of the, you know, having to do both patterns, taking a octal number to decimal, then a decimal number to binary, something like that. So be familiar with the shortcut pattern. So certainly these, you know, the bits versus bytes conversion. My gut feeling is on this exam, I'll probably have one number conversion with a maximum of 2 number conversions and one bits bytes type conversion. You know, those are things that you definitely need to know in this class. In future exams, you'll probably only have one conversion question of any kind. But in here, we've spent some time this first 8 weeks talking about those things. They're important concepts. So I can see as many as a third of the exam being around those things. Three, you know, almost a third, 3 of the questions. I won't ask any questions about, you know, we were using this for kind of giving the idea of bits and bytes, but I'm not going to ask you questions about high definition TV and stuff like that specifically. This was an applied example of, you know, number of, you know, gigabytes that a HD movie takes, something like that. It would be fair game to talk about the bits versus bytes in terms of speed instead of capacity. So bits per second. So like one of the things we talked about in here is like an internet connection. If you have a 200 megabit per second internet connection, that's actually a 25 megabyte per second internet connection. And how long might it take to download a 2 gigabyte file, something like that? That would be a kind of a fair game type question. So these are, you know, technical type things that we can apply that bit versus byte stuff to. But from this example here, I would not ask you, I mean, I could potentially give you some data for like number of pixels and the size of each pixel or something like that. I don't know that I would do that. That's almost like too much trouble when you can ask the same question a different way. But you wouldn't have to memorize the resolution of high definition TV of 1920 by 1080, that kind of stuff, or what's 4K, that kind of stuff. That's unrelated to our stuff. Certainly understand high level, low level versus machine level. You know, the movement between those and why computers ultimately like machine code, zeros and ones. Humans don't like that. We don't want the 2-button keyboard, so we operate at a much higher level, and then there's a kind of a transition between the two. You know, we didn't work at low level in any sort of, we looked at like low level, the hello world program in Linux we looked at. at an assembly level, but that wouldn't be something I'd test you on. So really, I want you more to have an appreciation for that transition. But understanding that computers ultimately are at that 0 and 1 level and humans are not. It would be fair game, but I wouldn't ask a real detailed question about that. Compiled versus interpreted, again, fair game, interesting. I wouldn't put it on that high priority list. Certainly understand what that means. It could come into play maybe as part of another question or something, but I probably won't ask you anything directly about that. Loosely typed versus strongly typed, probably a little bit more important than compiled versus interpreted. Just that idea that in Python, when we create a variable, we don't have to define what kind of value is in that variable, and that allows us to pull some stuff off that is more complex in other languages. For instance, like more recently, we've been looking at how do we store collections of things, right? So we started off like, oh, maybe I'm going to store information about a person where bucket 0 is their first name, bucket 1 is their last name, bucket 2 is their age. Well, in that situation, I'm using a list, a collection, to hold 2 different kinds of information. I have strings and I have numbers for the number for the age, right? Where in like Java, if I created an array, I have to choose, is this an array of strings or is this an array of ints? I can't store both kinds in there without taking some additional steps of building my own object type to store that kind of stuff in there. So it does become a little bit more complex. So loosely typed languages do give us some advantages versus strongly typed languages from a flexibility perspective at the cost of speed. So understand that concept. General purpose versus domain specific, unimportant for us right now. A very high percentage of the languages you'll ever run into are general purpose. Domain specific is if you go and get your degree and then you take it into some very specific industry where they're using a kind of almost always it's going to be like, a language that is based on the C programming language, but only has like 13 functions or something like that you have access to for making a dishwasher run, stuff like that. So even when we say domain specific, they're very much based on a general purpose language, but with one hand tied behind your back type thing. And we don't have any context in here for that. So it would be very difficult for me to ask a question about that. Certainly object-oriented, not so much object-oriented versus procedural. We have seen that, but we haven't really driven home that point. Up until recently, we've effectively been writing all of our Python code as procedural code. Here's a code, here's some functions I wrote up here, I'm calling them from down here. That's procedural, one big monolithic type of program. Now we're starting to transition into this object-oriented model where we're kind of creating pods, where our code, it kind of exists, in today's homework, you had to write a dice class, right? Do we have a dice collection too, both of those? Whatever, I'll look at the assignment. But we had at least one object, maybe we had to create 2 objects where we're kind of creating pods and then using those. That will not be heavily represented on this exam, but it will be extremely heavily represented on the final because we just started into that concept. So it would be fair game to write a class or something like that for this exam, but it would be something very simple. This was that example of object-oriented versus procedural kind of the mentality at the object-oriented telephone that looks like a telephone versus the procedural telephone that looks like a pile of wires. Probably won't ask you a question specifically about that, but certainly understand the difference that object-oriented code is an organizational model that allows you to bring a lot of your details into a pod. Usually it's called encapsulation in programming lingo. So that you can kind of conveniently pass around. If I need to give you, in real life, I want to give you my phone, you ask to borrow my phone, I'm handing you this object that is a phone that has all these abilities within it, instead of me handing you this box of wires and stuff. So just figure it out. That's just how it works in real life. So it's understand the organizational advantage of objects and how it just mimics how we solve problems in real life, which goes back to the idea of the job of a programming language is to allow human beings to solve problems in a similar way to how we already solve them in real life. Okay, so hopefully as you go back through this stuff, you'll start seeing, as much as you maybe love or hate programming at this moment, you'll start seeing that, oh, it's actually doing me some pretty good favors. I'm just not quite where I need to be at yet to fully use the tools. Something like that. I probably wouldn't ask like a loaded question like which language is the best or what kind of language is the best, because that's all what's the right tool for the job type thing. You should understand where Python fits in that world, but I probably wouldn't ask you just a direct question. About that. Like I wouldn't ask you to just, regurgitate this slide, for example. In this class, we are working with Python, so questions are typically going to be written with Python in mind. But I mean, frankly, not that I'm encouraging you to do this, but I teach from the perspective that the language doesn't matter. So I mean, if you wanted to write all of your code examples in Java on the exam, I'm fine with that. I'm not encouraging that. I expect most of you to write in Python because a lot of you don't necessarily know all these other languages. And even if you have some Java background, I'd still encourage you to improve your Python and write the code in Python. But I'm not going to mark off points if you give me your answer in a different language. Chances are I've worked with the language, pretty high chance I can at least read it. So it's but I'd encourage you to consider Python if you would. But if you get desperate, I can look at whatever. All right, and then this starts getting into our syntax stuff in Python. I'm not going to ask you what is a variable, but you should certainly be able to create variables in Python. You should certainly be able to ask questions, conditionals, write loops, write functions, read. If I give you code that I ask you to read, you should be able to, know about all those things. When I have a function that takes some parameters, how do you call this function? That kind of stuff. So all these are syntax type questions. You should know all the Boolean operators, but these are things you probably knew before you walked into class, with the, exception that when you check equivalence, you use the double equal sign, something like that. But these are things you've had in math for years and years and years. The and or stuff you should be familiar with. I will not ask anything about bitwise operations. That was more of a, remember when you had like the single ampersand or something like that. I showed you this, the 7 exclusive or 3, this thing, and this gives you a weird answer. That's doing it at the bitwise level. So each individual, like the 1 XOR 0, the 1 XOR 1, the 1 XOR 1, and that gives you a different answer. I will not ask anything about bitwise stuff. Many of you should be taking CSC200 next semester, which is the computer organization and architecture class. I think Dr. Locklear is teaching that class. In there, you'll do bitwise stuff and operating at that zeros and ones level. That's really talking about what's inside the CPU and how the CPU interacts with the memory and that kind of stuff. Not you'll work with assembly language in there, a low level language, but that's the class where that's important, or something that you might be tested over. I will not ask you the bitwise thing. This was more of a, if you ever forget to finish writing your Boolean operator and you get a strange answer, this is why type thing. I won't ask anything about this. It is important in the big scheme of things, but not for this particular, competencies for this class. So understand the client server model, how web applications are put together. This is really a definition of kind of our modern, software application, where we have things that, you might have an app that's on your Android or iPhone and it's talking to the cloud, right? It's pulling in weather data or stock data or whatever it is. I mean, so modern day applications follow this client server side type of situation, but that's not important for where we are right now. This is more of a, how does it work type situation. Same thing, RESTful APIs. This is an important thing. This is something our 460 class goes into specifically. You'll be writing RESTful APIs in there, but not something that is part of this class's competencies. Data representation languages, same thing. I'm not going to ask you something very specific about it, but understand that they are different than programming languages. Programming languages, 100% of them give you facilities for remembering things, asking questions, and repetition. Data representation languages allow you to organize things. JSON being probably our modern cool kid, and these guys look a lot like dictionaries. So you'll have questions in here dealing with dictionaries and the role that they might play in your program, which happens to be a way of representing name value pairs. Okay. I won't ask anything like specific, like you won't have to regurgitate this chart or anything like that. You should kind of have an appreciation for the history of our languages, but we have enough stuff to focus on around Python and the things that we've applied here in this class, where this is more of a historical, you know, ballparky type thing. Where do we fit in the world of historical languages, but not something I'm going to specifically, you know, ask you about, like the relationship between Java and C# or anything like that. Okay, so know how to do variables, be able to write functions, be able to read functions. So here's a whole bunch of sample code, be able to do mathy stuff. Right now, a lot of our fair game type problems that we're writing, just because of our current skill level in programming, is going to deal with like doing something with math, you know, summing up a bunch of stuff, getting the average age of a bunch of people, this kind of stuff. Realistically, I probably would not have you do anything with exclusive ORs on an exam, not just the bitwise, but even normal exclusive ORs. Your go-tos tend to be ands and ors. Exclusive OR, that one or the other, but not both. Interesting enough, but actually more of something that you will maybe look at in the 325 class. Because something you might talk about in there is the idea of, you know, when they build processors, for instance, they tend to do everything with either NAND or, so NAND is a not and gate. You'll talk about these things called gates, or not or gates. So they'll solve problems in a very weird way using a whole bunch of not ands, which is something that you look at like, well, I wouldn't write software with that in mind. You know, that's kind of a weird thing. I use ands and ors, right? And every now and then I'll throw a not in there. Is something not equal to something else, that kind of thing. But in computer organization and architecture, the way these companies can drive their price down is buying things in bulk. So what there's a whole science behind is, how do I create an and using a combination of other circuitry and NAND gates? That way they can have this giant box of NANDs that they buy for pennies on the dollar, and they can solve all their problems using those. So those are things that kind of become more interesting when you start talking about how processes are actually made versus the more straightforward way of looking at it. So I probably won't ask anything that would require you to deal with an exclusive or bitwise Boolean operators. Certainly be able to work with strings, length functions, all that stuff. So these are all super fair game for write a program that reverses a string or counts the number of you know, even numbers in a list, stuff like that. String concatenation. String formatting, I would say, is probably important on this exam. That's something that's going to be taken for granted in the future, but it would be fair game for me to ask a question to, you know, assuming you have these three variables and you want to create a output that says, you know, my name is Mike Littman and my age is something, you know, write the necessary line of code that will format it that way. And you can do that with concatenation. You can use an F string. You can kind of choose, but give me a viable solution to that. You should be able to work with the find function, specifically that, remember that highlight of it is that it gives you a -1 if it doesn't find something. That could be an important tool for us. I probably wouldn't have you do anything with the replace function. Find is kind of like a go-to move for stuff. Replace is an interesting convenience, but you don't need to like memorize that or anything. Same thing, the strip function is important, might be used, but I probably wouldn't have you write it. I guess it's possible if I'm asking you to read my code, I might put that in there and you should know what it does. It removes the, the default version removes the preceding and trailing spaces, so you don't have any extra spaces on it. Fairly low chance I'll use that function, but I wouldn't ask you to write something with it. I'd ask, if anything, you would have to know it when you saw me write it. Be very familiar with lists. So our collection types are important. So strings, collection of characters; lists, collection of stuff; dictionaries, collection of name value pairs. These are going to be our bread and butter for this exam. Combining lists, not really important. That's something that is we didn't really do very much and isn't necessarily overly, let's say, common. We didn't really talk about mutable versus immutable collections because we didn't talk about tuples in here. Tuples are lists that can't be changed. But so this slide is trivia type stuff. Mutable means changeable. You're allowed to change it. Immutable means not changeable. You're not allowed to change it. I won't test you over that. Here's that tuples thing. Notice they're in parentheses instead of square brackets. That's like a hard-coded list that can't change. Again, we didn't really talk about it in here, but it's a thing. It exists. But I won't be testing you over it. Dictionaries, fair game, definitely fair game. Be able to create a dictionary, be able to use dictionaries, be able to loop through dictionaries. User input, you should be able to do that. I don't know that I would ask you to do that on the exam, prompt the user for something and then, determine whether it's even or odd, something like that. I guess it would be fair game, but usually I ask questions along the line of write a function that takes a value. I don't care where you got the value, but write a function that takes a value and, returns one thing if it's even, returns another thing if it's odd, that kind of thing. Okay, you should be familiar with our couple of functions for converting our types. The ones we've really worked with are like the int, the char, and the float. That will take that guy and turn it into a string representation of those, and we'll turn it into a numeric. You can do math with it, but int and string are kind of your two go-tos. But there's some other ones that exist here. I wouldn't ask anything like weird. Some weird conversion that we haven't done before. Variable scope is something you should be familiar with. It would be fair game. It's hard to ask you to write a question that deals with that, but it would be fair game if I give you some code that maybe has a couple of functions, and I ask you what the output of something would be. I could ask a question of like what variables are in scope in a certain function. So I might show you three functions and then ask you to tell me what variables are part of the scope of a certain function. And you would have to know that it's only the variables that were defined in that function or globally, not the variables that are in the other functions. So remember, we had these blue guys here are our other functions that we had. So things that are in this global scope, they're available in all of these functions. But my variable a first name that I define inside of display a person is not accessible here in these two functions because it lived and died with this guy. So you should understand scope from that perspective. You should be able to wield scope as well. You should be able to write code that has that deals with scope, but it's sometimes hard to ask a question specifically related to that. Study guides are kind of a double-edged sword. So I usually don't provide study guides specifically, but I mean, if you go back through and do your homework assignments that you've had in here, that would be good practice. If you don't look at the solution, just kind of write it yourself. The reason study guides are a double-edged sword in classes, if a teacher gives a study guide and then asks something that's not on the study guide, then they get thrown under the bus. So this is kind of my version of a study guide that I'm doing right now by going through the slides and saying, as I'm writing the exam, this is what I might put on there, what I might not put on there. Okay. So for example, here, like Unit 2 assignments, I may not have asked you to write all of these. So these would be other little sample things that you can do. I think sometimes I gave an alternate assignment or something. But those would be practice things you could go through. All right, so be able to write Boolean expressions, if statements, all those things, for loops, loop through strings, loop through dictionaries, loop through lists, be able to work with our collection types in the context of iteration or repetition, be able to write functions. Definitely know the difference between a function returning a value and a function printing a value. So if I tell you to write a function that does X, Y, and Z and then returns the result, make sure that you know that returning the result is different than having your function print the result inside of it. There is a difference between those two. Okay, and that'll be lost points because when I ask you to write a function, I will specify what the function will do, and I'll say either it should return it or it should print it. I might say it should do both, but that's an important part of writing a function that does something. Be able to call functions. Here's that print versus return dealy. I even give you an example in here of ones that print versus ones that return. So make sure you're comfortable with those things. That idea of pass by value versus pass by reference, when we pass lists or dictionaries, those collection types, and we make changes to them, those changes are permanent. Sometimes it's hard to ask a question specifically about something like that, but that would certainly be fair game if I gave you some code to read where I passed a list to a function, I changed the list, and then I printed out the list somewhere else in the program, and you should know that that list was permanently changed. You should know that lists are passed by reference or passed by address, which means that when I make a change to it, that change has side effect. We will notice that change in other parts of the program. So that would be fair game, and that would not count as me tricking you. That would count as you understanding that when a list is passed, modifications to that list are permanent. If a number is passed, modifications to the number are not permanent. I think the example we used in class is if I give you a copy of a quarter and you do something with that quarter, it's not going to have an impact on the other quarters that are in my pocket. As opposed, that would be like passing a number passed by value. Whereas if I give you the address where my house is and then you go and spray paint my garage, when I get home, I'm going to notice because there's only one garage and it's now been spray painted. So a bunch of conversion stuff here. Understand the concept of pointers. We really haven't worked with them. I don't know if I would ask a question specifically about that. I mean, we have worked with pointers when you pass a list. That list is passed by address, which is a pointer, but we haven't necessarily had real direct use. So pointers might be something that comes up on the second exam in a more direct way. Okay. So as you're studying for this again, it would be helpful, as you go through here to look at code examples I gave you in the slides. So the slides have a lot of supporting stuff in it that I did not necessarily do identically in class, or I gave you alternative examples because sometimes I did stuff as we got to it and then it's somewhere else in the slides and I didn't remember it was coming up. But so there are plenty of code examples in the slides with commentary over to the side that tells you kind of what it's doing. So that would be another good thing to look at. All right, so then this is just getting into where we're at right now when we started talking about classes. Definitely be familiar with the self keyword. So I would be at this point asking you kind of our introductory questions about writing objects. So you should be able to write a simple object that just stores maybe a couple pieces of information, like a person, first name, last name, age, that kind of thing. But on an exam, I probably wouldn't give you a specific person example since we've used that several times. Maybe I'd ask you to, create an object that's a, representation of a car, where you keep track of the number of wheels, the towing capacity, some stuff like that. You should be able to create an object that keeps track of those 2 or 3 different things. Understand the concept of the self keyword. It's how an object refers to itself from within itself. All right, and now we're back to where we are today. So with all that in mind, are there questions about the exam? Any particular thing you want me to go over an example of or something like that? Go ahead. Okay. So is that the idea that all programs begin and end with main? Okay, so I mean, if we, is there something specific about it you want me to talk about, or just kind of reiterate what the, okay. So, I've made this statement that all programs begin and end with main. And actually, if you notice in the slides way back at the beginning, I think I give, there's a slide about, here's the, Python program template. I won't click it because I'll lose my space, but that has like the thing that has main in it. So you have this idea that all programs begin and end with main. Well, in Python, we can just write a program that just sits out in the middle of nowhere and doesn't have anything like main in it. So if I come in here and I just say new, and we'll just say print hello world. So this is a simple Python program. It's going to want me to save this. We'll just call this guy test2.py. What is this guy complaining about? Oh, whatever. So there's our hello world printed. So we don't have anything with main here. So what I'm telling you is something under the hood happens. To get your program running, but because I'm just printing this in the global scope here, and because it's an interpreted language, that concept of it being an interpreted language makes this a little bit more deceiving when it comes to that concept of main. So to make Python look more like your traditional languages, and it's not necessarily a fake thing, because you'll see many Python programs written this way, I go ahead and I create a main function. Now you could call this guy elephant if you wanted to. I'm just happening to I'm calling it main to be consistent with the history of these things. So if I come in here and I just move this code in there and I run this, you see our program does nothing now, because now I've created a function that I happen to have named main that does something, but I'm never actually calling that function. Now I can come down here and I can just, in the global scope, say call main, and now this program will do something. So there's my hello world, because in the global scope here, I'm defining a function and then I'm calling that function. But again, this is kind of an organization of Python thing where anything that is in the global scope gets executed. So right here, I have a definition statement. So this will execute and create a function that I could later call. This line is a call to a function. So it will execute, which will call a function that I've already written. It prints out hello world. So again, this is a perfectly viable functioning Python program, but it's still kind of misleading in the context of how modern programming languages work, which is why I throw that thing in there where Python has a built-in, so for instance, if I say print underscore underscore name underscore underscore, you see that it's showing you that the main method is what's getting called. but this is this built-in Python thing called underscore underscore main underscore underscore. So that's evidence that all programs begin and end with main, even though Python doesn't do a real great job of showing that to you. So with that in mind, these underscore underscore things are something, these are things that are kind of built into Python. So with that in mind, I like to write something that says, well, if underscore underscore name underscore underscore is equivalent to underscore underscore main underscore underscore, which we know it will be, because all programs begin and end with main. We just show that it will be. We know that that's what's going to call. But I'm just explicitly asking the question, and then in here, I'll just call my function that I wrote. That way in main, I can create my own scope, and I don't have to use that global scope very much. So the output of this program will be the same as we were able to get from a one-liner before. And you'll say, well, why didn't you just write it as one line? That seemed better. But this explains a lot more about what's happening under the hood. I've created my first function that's going to kind of drive my program. I happen to call it main for historical reasons. And then I'm going to prove that Python does start off with main by asking this question: is the name variable, which I didn't write, that's something built into Python, is that currently equal to main? We know it will be, because that's how Python's interpreter works. And if it is, well, I can just write my code in here if I want, or I'm just putting it inside of a function I wrote here. But you can name this function whatever you want. If you call it LOL, just make sure you call LOL from down there. Does that make sense? All right, so that's kind of our, I guess, our deal with main. Let's see. Okay, and in our Boolean operators. So we can create a couple of variables. So we can maybe say temp is equal to 55. Sunny is equal to, what was it, capital TRUE? Yeah. So maybe I say in here, if temp is greater than 50 and actually in Python 3, I think it's just the word and Sunny, print, let's go for a walk. Else, let's play a board game. Something like that. So I created a couple of variables that have some values in it. I'm asking a question here that's using an and. So I'm saying if temp is greater than 50, if it's at least 50 degrees outside, well, if it's at least 51 degrees outside was what that says, and it's sunny. So I'm just saying sunny here because Boolean expressions are any expression that boils down to a single value of true or false. Well, sunny boils down to a single value of true or false. Now, as a beginning programmer, you might prefer to see the redundant version of that, where you like saying, well, sunny is equal to true, even though sunny is true. So you're really actually saying true equal to true, which is always a true statement. But this isn't incorrect, it's just redundant. So you might prefer it looking like this, where you're saying, I'm asking two questions here. Is the temperature greater than 50 and is it sunny outside? If both of those are true, let's go for a walk. So there's our let's go for a walk, because it is greater than 50 out and it is sunny. If I change sunny to false and I run this again, now it says let's play a board game. Because yeah, the temperature was okay, but it's not sunny out, so it's probably going to be a little cold. 55 is going to feel different depending on whether it's sunny or not sunny. Something like that. So that would be a use of and, or would mean that in this case, I just got the let's play a board game, and now since I'm using an or, only one of these needs to be true. So since only one of them needs to be true, is temp greater than 50? It is. Is sunny equal to true? It's not, but that doesn't matter. Since this part was true, it's not even going to test the second half. It won't even check it. So we'll get the let's go for a walk. So there's a code example with ands and ors. In a lot of languages, an or, modern C languages, an or looks like that. You know, it's a syntax error in Python 3. I actually think that is what they use in Python 2, which is kind of funny how they went to Python 3 and they deviated from, so in C, C++, Java, C#, Objective-C, and Swift, that's the OR operator. In Python 3, it's that, which is fine. Just those are the little nuances between the couple of languages. All right, anything else you want me to go over? Okay, so then let's look at the homework assignment for today, the dice roller dealie. So we were to create a dice class that keeps track of a number of sides for a single dice object. Let's do that first. So I'm going to create a class called dice. And we're going to define the init method. And the init method is going to take in a number of sides for my dice object, and we'll say self dot number of sides is equal to number of sides. Now I'm going to go ahead and import random up here because we're going to need our random guy here. So as it stands right now, what does my dice let us do? Well, I can now say D6 is equal to dice 6. D10 is equal to dice 10. So I'm creating two different instances of the dice object. I'm storing one inside of a variable called D6, and it's going to be a dice who has a 6 for number of sides. And this one's going to be a dice who has a 10 for number of sides. Now, I don't remember if I showed you this last time, but if I print out D6, what's the output going to be? This goes back to what we talked about a few minutes ago about pointers, where we're just starting to kind of limp into seeing pointers. This guy's going to be, actually, I'm going to go ahead and print out D6 and D10. Now, beginning programmers usually say, oh, well, that's going to print out a 6-sided die, or that's going to print out a 10-sided die. Well, what does that mean? What this is going to print out is it's going to print out the memory address where D6 lives, the memory address where D10 lives. Remember we talked about how memory in a computer works? Everybody lives on one big long street. This is the house number for D6. This is the house number for D10. Notice they're very similar, except this is a 7-8 and this is a 7-6. Different house number. Make sense? All right, so that's what we're actually seeing if we print out that object. Now, we want these objects to do something. So in the homework, we're going to say a dice object should provide a roll method that when rolled generates a random number between 1 and the number of sides. So we're going to go ahead and give an ability to our dice object. So we're going to say def roll. And that's not going to take any parameters. Remember, we still pass self around. That's how object-oriented programming is accomplished in Python, where self being the key word, that it's how an object refers to itself from within itself. So what do I want the roll method to do? I wanted to generate a random number between 1 and self.number of sides. So I'm going to go ahead and it returns that value. Not prints it, returns it. So I'm going to return random dot, what was it, randint, one self number of sides. So that's what this roll method does. It returns a random integer between 1 and number of sides. I think we saw last time that it is including that number of sides. So now what I can do down here is I can say for I in range 1 to 10, let's say, I'll just go ahead and print d6.roll. So I'll roll my 6-sided die 10 times. Actually 9 times in this case. So there's my roll of my dice. And if instead of my d6.roll, I do a d10.roll, now it's going to give me values between 1 and 10. So we've defined an object up here that is built in terms of his number of sides, and then we've given it one ability. He knows how to roll himself. And what does roll mean? It means I'm going to return a random number between 1 and however many sides this guy has. So now I can conveniently build a d6, build a d10, and I can roll those guys. But now notice that, what will the output of this program be? If I gave you this on the exam, and I said, what's the output of this program? What will it be? And this kind of goes back to our idea of all programs begin and end with main. Yep, it's not going to print, and it's not even storing it either. So this guy right here is going to boil down to a number between 1 and 10. And what am I doing with that number? Nothing. I'm not printing it. I'm not storing it. I'm just letting it die. It's going away. So all programs begin and end with main. What does main say to do? It says create an instance of a 6-sided die. Create an instance of a 10-sided die. Do something 9 times. What am I going to do? I'm going to roll my 10-sided die 9 times. And what am I going to do with that roll? Nothing. So here's the output of that program. It's nothing. That make sense? So that's part of that skill in reading code. As we look at this, we know this is going to boil down to a number between 1 and 10, because that's what the roll method does. It returns a random number. It returns a random number. It does not print a random number. It returns a random number. That's what this guy does. He returns a value. So that's what this will be. It will boil down to a value between 1 and 10. And what am I going, then I ask myself that follow-up question. This is the important follow-up question. What does it do with that random value? Right now, it does nothing. I can choose to print it if I want. And now I have output. I can also choose to store it. Maybe I create a list called the roles, and I say the roles dot append each of those roles. What would the output of this program be now? I created a list, a place to put all my roles. Every time I rolled the dice, what did I do? I appended it to my list of roles. What did I do with the list of roles? Nothing. Output still nothing. But now I can come after this for loop and I can print the roles, and now I'll get my collection of roles that I built up through that loop. Make sense? That idea of what does code actually do? Slowing yourself down and asking yourself the individual steps. All hard programs are made up of a bunch of easy parts. When we look at this code, every individual line of it isn't overly intimidating. It's when you put them all together and you start saying, well, what does this thing do as a whole? That's that skill I'm talking about on the exam, where I'm going to give you some code and say, what does this do? And I mean, you basically just had some examples of it. I might give you a program that's kind of like that size. And I say, what does this do? Okay. So, other questions you want me to go over? I think that was the homework, right? Yep. So, this is your homework assignment, let's say. I'll go ahead and copy that code. I'll throw it up on Slack. Oh, I think some of you have seen me do this before, but just as a reminder, if you ever want to post code up here, although it looks like, I don't think Ben used that thing to post that code, so he probably had to do some indenting and stuff, but unless, does it indent it for us? Oh, it would. But in any case, usually if you want to post code, do create a code or text snippet in here. And then when you paste it, it kind of maintains the indentation and stuff. It also gives you line numbers, just a friendlier way of putting that up there, I guess. You know, pick your poison, but it also will be kind of a shorter thing rather than, you know, a wall of code. All right. And let's see. Oh, I'm good. Somebody have a question?
Yeah, can you hear me?
Yep.
Okay, so if we want to have the dice like print out their roles in a sentence, do we have to put the print within the class, within the function? I mean,
Well, tell me what you wanted to say. What do you mean print out as in a sentence?
well, because like I guess for my homework, I had it say that you rolled a 4 out of a X-sided die. You know what I mean?
Mm-hmm.
And I did that within the function, and I didn't actually ever return the answer. I just printed it. But I'm wondering if there's a way to like do that down at within the def main function
Well, yeah,
instead of putting it.
yeah. So you could do something like this. So down here you could say print, and we'll do an F string here. You rolled a blah on a blah sided die. And then inside here, we would say D6 or D10 dot roll. And here we would say D10 dot number of sides.
Perfect.
And there's you rolled a 1 on a 10-sided die, so on and so forth. Now, if you wanted to build that into your dice class, though, you could maybe create another function called, maybe called a pretty roll or something like that. And what this guy would do is he would effectively have that print statement in it. And instead of D10.roll, it'd be self.roll, and it'd be self.number of sides. And then what we can do down here is we could say, what can I scroll? We can say D10 dot pretty roll, and he would roll and kind of announce himself, never actually returning the value. So there's that. So you could build it into the class itself if you wanted to. you just want to think about classes as kind of having abilities where you probably definitely want to have the ability to roll the thing and get the value so you can use it for other things. But if you want to have kind of a purely visual experience, you could, I called it pretty roll, which gives you a nice sentence structure for it, but it also did not give us the values. You could have it do both. You could have it say,
The same.
you could say value is equal to self.roll. And then we can print out value here, but we could also return value in case somebody else wanted to go and use that for something else. And then we could collect that, the roles dot append this thing. And then afterwards I can print out the roles. So now it'll give us our pretty prints, but then it'll prove that, oh, we also captured the individual roles, because pretty roll did both. It gave us some visual output, and then it also gave us the actual value we rolled, and we can do whatever we wanted with that. What did we do? We appended it to our list. That makes sense? Okay. Well, we're out of time. If you do have additional questions, feel free to put them on Slack. It would probably be best to put them on Slack in the 200 channel so that when I answer or if somebody else answers, everybody can see it. But I'm also happy I'm around all week, so I'm happy to meet with you on Zoom if you want to cover something specific. But in any case, so we don't have class on Thursday. We won't meet next Tuesday because we'll have the exam, but the exam will be during class time. It'll be open from the beginning of class, close at the end of class, and I'll be live to answer any questions during the exam, in case you're stuck. All right. Questions, comments, concerns, bribes. All right. I will see everybody on Tuesday.